Alright, so this is the FPGA board after I've programmed it with my arithmetic modules and programs. Basically, all it does is it takes an input based on these switches on the bottom. The first 8 here represent the first number, and then the second 8 on this side, the second 8 switches represent the second number as an 8-bit binary number. The LEDs up here that light up represent the output. So we treat the second number here as 0. We can just go ahead and turn on these switches, and we see that the switch corresponds to its LED, meaning, for example, that this one representing 4 or 100 in binary, 4 in decimal, turns out to be 4 in decimal or 100 in binary up there. Pretty easy to understand. The one difference is, since it is 2's complement, this switch over here, it's the most significant bit for the first number, so it lights up 2 switches here, and it shows a 9-bit. Basically, the output is going to be a 9-bit output, 9-bit binary output, since it would be a negative number. All right, so I'm just going to go ahead and start adding some numbers together, really simple ones. Right here would be this one, number 1, plus 1 is obviously going to be 2 or 10 in binary. Pretty easy as well. If we add, let's say, 3 on this side, and then we add just another one here, which is 4, we get 111 or 7 in binary. Those are some pretty low ones, just checking that it works. Now let's just go ahead and take a little bit higher numbers, just to show that this can add positive numbers first. So we're going to put in the binary 100. So that's going to have a 1 here. I've already calculated some of these numbers over here just to make sure that they come out right. So it's 100 plus 25. That's what we're going to do first. So it's got a 1 here, and then we go 2 over, and we have 2 more 1s. There's an empty 0 there, and then here's where the second number starts. So I'll go ahead and put that one up for 25. Skip 2, and then 1 and 1. And then we have 3 empty ones right there to represent 25. And it turns out to be 1 1 1 1 1 0 1 is the output. And that does turn out to be the result of 100 plus 25, or in decimal, 125. All right, let's try it for another number. This time we're going to choose 2 negative numbers. Let's try negative 124. It's going to have a 1 here, and then it's actually going to skip. Oop, I almost dropped it just now. Actually, I did drop it. It's 1 2 3 4. And then we're going to turn this one on here. So that represents 124. And then right after that, we're going to have 100, that's negative 124. Then it's negative 103, so 1 here, skip 2 zeros, then that one, and then skip those 2, and then the most significant bit is, of course, that. Negative 124 plus negative 103 is negative 127, which should turn out to be 1 0 0 0 1 1 1 0 1, and it looks like that's what we have on our output. All right, and I'll just turn those off. Now we're going to go ahead and add a negative number to a positive number. Let's go ahead and try negative 124, so we'll actually turn those ones back on. All right, so now we have negative 124. Let's see, actually it's going to be like that. That is negative 100. I am so sorry. Let me just double check that this is correct. Okay, now that is negative 124. All right, and then we're going to add that to 103 this time. So it's going to have 1 2 3, skip 2, and then we'll have 1 and 1. And this turns out to be correct as well. It's negative 21, or in binary 1 1 1 1 0 1 0 1 1, and we see that result, negative 21 is 1 1 1 1 0 1 0 1 1. All right, and let's just make sure we can test some of the extremes just to make sure that this program is in fact working. So we'll go ahead and why don't we just try adding what will happen if we add the 2 most significant bits. That gives us actually our furthest from 0 number. That's 1 and then 8 zeros after it, because we're adding basically, what is it, negative 256 or negative 128, something like that. And well, I think in total it would be negative 256 because it's adding those two together. If we add the 2 highest positive numbers, however, which would be LD6 and these two, then we get basically this LED lit up right here. So we have just one of them. If we double it, that works. And basically, if we double any number, in fact, so if we double this one, so LD4, and then 1, so let's go 1, 2, 3, 4. Sorry, one more. That one lights up the very next LED. Kind of interesting how that works. Basically, literally, if we double 2 of the corresponding numbers, it'll just go on to the next one because that's sort of how binary works. All right. And truly, if we do any number on this, any 8-bit binary number, we've accounted for overflow, so it will end up being the correct positive number. If we count this LD8 or the 9th binary digit from the beginning, it will show up as the correct result. So there we have it. If you have any questions, let me know, but thanks for watching.